So, Peter asked a very interesting question. What would happen if everyone on Earth aimed a laser pointer at the moon at the same time? Would it change color? Well, the quick answer is no. But let's break down why. First off, we have to consider that not everyone can see the moon at once. Sure, we could gather everyone in one spot, but we've already learned that's not as simple as it sounds. Most people live between 0 and 120 east, so we'll need the moon to be over the Arabian Sea for the best chance of hitting it with our lasers. Let's say it's a quarter moon at night, so we can compare the effects of our lasers on the dark side versus the light side. A typical red laser pointer is about 5 milliwatts. Even a good one would have a beam tight enough to hit the moon, although it'd be spread out across a large part of its surface. Now, let's assume everyone aims perfectly. What happens next? Well, nothing. Here's why. The sunlight that bathes the moon and Earth already provides about a kilowatt of energy per square meter. The moon's cross-sectional areas are on 10 trillion square meters, and its bright side alone gets around 6 petawatts of sunlight. In comparison, our collective 5 μW lasers would only add up to about 30 megawatts of light, which is 200 million times weaker than sunlight. That's why we wouldn't notice any effect. Now, let's get a little more ambitious and try a 1-watt laser. A 1-watt laser is dangerous. It's strong enough to blind someone, burn skin, or even start a fire. These lasers are pretty much illegal, but that hasn't stopped sketchy $200 listings for 1-watt blue flashlights online, usually described with a very narrow beam wink. I've seen one of these myself, and trust me, they are terrifying. Never buy one unless you're wearing safety glasses worth more than the laser itself. So, let's say we somehow get our hands on these 1-watt lasers. The effect on the moon would be, well, still not much. All those lasers combined would light up the surface of the moon with about half a lux, which is half as bright as moonlight here on Earth. The sunlight at 130,000 lux would still drown out the lasers. What if we cranked it up even more? Time to leave lasers behind and bring in something more powerful. Imagine the night sun, a searchlight mounted on a helicopter with an output of 50,000 lumens. It's capable of turning night into day on the ground. If we focused its beam down to a half-degree spot on the moon, we provide 20 lux of light, which is twice as bright as the ambient moonlight on the night side. But still nothing on the bright side of the moon. Let's take this up a notch again. Imagine we're using the brightest spotlights out there like the ones in Las Vegas, over 1 million lumens of light. But still, it's not enough to overpower the sunlit side of the moon. Though, it's definitely visible. Now, we're talking. But what if we pushed even harder? Next up, let's use something like the Boeing Y-1, a megawatt infrared laser mounted on a 747. It was an experimental technology from the US Department of Defense. If we somehow make a visible light version and hand one to everyone, we'd finally match the brightness of the sun. But here's the kicker, it would use 5 petawatts of power, double the world's entire electricity consumption. We still haven't caused the moon to change color, though. Now, let's really go wild. Picture a megawatt laser on every square meter of Asia, with 50 trillion lasers. Powering this array would burn through the Earth's oil reserves in about 2 minutes. But for those 2 minutes, the moon would shine as brightly as the mid-morning sun. By the end of it, the surface of the moon would heat up and glow. Alright, now we're entering the realm of complete improbability. The most powerful laser on Earth right now is at the National Ignition Facility, 500 terawatts of ultraviolet light, but it fires in tiny pulses lasting nanoseconds. What if we could somehow make it continuous, power it up, and give everyone a turn to point it at the moon? This would instantly turn Earth's atmosphere into plasma, burning everything on the surface and killing us all. But let's ignore that for a second. Assuming the lasers could somehow pass through the atmosphere, they would still have enough energy to vaporize 2 meters of lunar bedrock per second. The moon's surface would become a plasma, blocking the laser beam. Eventually, this would turn the entire surface of the moon into a kind of rocket engine, blasting away chunks of rock into space, a process known as laser ablation. This is actually a potential method for spacecraft propulsion. Now, let's take a wild guess. The moon would slowly start drifting out of Earth's orbit. Over the course of a few months, the moon would be pushed so far that it would escape Earth's gravity and enter an unstable orbit around the sun. This bizarre orbit could eventually send it either into the sun, out of the solar system, or even on a collision course with Earth. But, at this point, we've probably already earned whatever happens next. So, there you go. That's how much power it would take to change the moon in any noticeable way. But I think we can all agree trying to change the moon with lasers might just be a really bad idea.